Welcome to this comprehensive beginner's guide on C-sharp anonymous functions and inline delegates. Throughout this video, we will demystify these powerful C-sharp features, providing you with a solid foundation to enhance your coding skills and write more efficient, readable code. In this video, we'll embark on a journey to explore the core concepts of anonymous functions, understand their practical utility in various programming scenarios, and learn the step-by-step process of implementing them effectively within your C-sharp applications. Specifically, our learning path will meticulously cover the fundamental delegate keyword, delve into the nuances of inline delegates, and conclude with essential best practices to ensure you use these constructs correctly and efficiently in your C-sharp projects. As the name clearly suggests, an anonymous method is fundamentally a method that lacks a formal, explicit name or identifier. Unlike traditional named methods, it is defined directly where it is used, making it a unique and powerful construct in C-sharp. Anonymous functions are essentially inline methods, meaning they are defined directly within the code where they are invoked, rather than requiring a separate, distinct declaration block. This characteristic contributes significantly to their conciseness and immediate utility. They provide the flexibility to define a method precisely at the point of its requirement, frequently serving as an argument passed directly to another method. This capability streamlines code and enhances the expressiveness of your C-sharp programs. You can effectively think of anonymous functions as compact, self-contained mini-functions that you have the ability to create and utilize instantaneously, precisely when and where they are needed, without the overhead of formal method declarations. In C-sharp, anonymous methods are formally defined using the delegate keyword, which specifies their signature. Once defined, they can then be seamlessly assigned to a variable whose type is a compatible delegate, enabling their invocation and execution. To illustrate these concepts more clearly, let's walk through a straightforward, practical example that demonstrates the fundamental structure and usage of an anonymous function in C-sharp. This will provide a concrete understanding. Our first step involves defining a delegate, which acts as a type definition for methods. In this specific instance, our delegate is designed to accept a single integer parameter and will not return any value, indicated by void. Following the delegate definition, we proceed to create an instance of this delegate type. Crucially, instead of assigning a named method, we directly assign an anonymous method to this instance, defining its logic right at the assignment point. With the delegate instance now holding our anonymous method, the final step is to invoke or call this delegate. We pass a specific integer value as an argument, triggering the execution of the anonymous method's defined logic. This complete sequence effectively demonstrates the entire life cycle of an anonymous method, from its direct creation and definition within the code, through its assignment to a delegate instance, and finally to its immediate and straightforward invocation. Anonymous functions excel particularly well for encapsulating short, simple, and highly specific operations that are intended for a single, one-time use. They prevent the need for creating separate, named methods that might clutter your codebase. Now that we understand what anonymous functions are, a natural question arises. Why should we incorporate them into our C-sharp development? Let's delve into the compelling reasons and significant advantages they offer to developers. A primary benefit is their remarkable conciseness. Anonymous functions significantly reduce the boilerplate code required, especially when dealing with simple, localized operations, leading to a more compact and easier-to-read codebase compared to traditional named methods. Another significant advantage is the enhanced flexibility they provide. Anonymous functions empower you to treat blocks of code as first-class citizens, allowing them to be passed directly as arguments to other methods, thereby making your code highly adaptable and modular. Furthermore, in specific contexts, anonymous functions can greatly improve code readability. By defining the logic directly where it's used, they keep related code segments physically close, which can make the overall flow and purpose of the code much clearer to understand. To solidify our understanding, let's now proceed to create another simple anonymous function, meticulously utilizing the delegate keyword. This hands-on demonstration will reinforce the syntax and practical application of these fundamental concepts. Our initial step is to define a delegate. Remember, a delegate serves as a type-safe function pointer. explicitly defining the signature, meaning the return type and parameters that any assigned method, including an anonymous one, must adhere to. With our delegate type established, we can now proceed to create an anonymous function. This function's implementation will be written directly at the point of assignment to our delegate instance, adhering strictly to the delegate's defined signature. Once the anonymous function is successfully assigned to our delegate instance, the final step is to invoke the delegate. This action will execute the code contained within our anonymous function, demonstrating its functionality in action. This comprehensive example effectively illustrates the entire workflow, from the initial definition of the delegate, through the assignment of the anonymous function's logic, and finally to the successful invocation of that logic via the delegate instance. It is absolutely crucial to pay close attention to the delegate's signature. The anonymous function you assign must precisely match the delegate's expected input parameters and its specified return type. Any mismatch will result in a compilation error. Inline delegates represent a more streamlined approach where the delegate variable is both declared and immediately assigned an anonymous function within a single, concise statement. This combines two steps into one, enhancing code compactness. By combining the declaration and assignment, this technique significantly enhances the compactness of your code. It reduces the number of lines required, making the intent clearer and the overall code base more streamlined and efficient. To highlight the benefits of this approach, let's now take our previously constructed example and rewrite it using the inline delegate syntax. Observe how the code becomes more condensed and potentially easier to follow. In this revised version, you can clearly see that the greeting delegate variable is not only declared, but also has its anonymous function assigned to it all within one single, unified statement. This is the hallmark of an inline delegate. It is best practice to utilize inline delegates primarily when the delegate is required for a singular, specific purpose and you aim to maintain maximum code conciseness. This avoids unnecessary separate declarations for one-off uses. Building upon anonymous functions, C# further introduces Lambda expressions, which serve as an even more concise and expressive shorthand syntax for defining anonymous functions. They are a powerful evolution in modern C# programming. The defining characteristic of Lambda expressions is their use of the equals operator, often referred to as the goes to operator. This symbol is central to their syntax, separating the input parameters from the expression body. To demonstrate the elegance and brevity of Lambda expressions, we will now take our familiar greeting example and transform it once more, this time converting it into its equivalent Lambda expression form. Notice the significant reduction in syntax. As you can observe, the code is dramatically simplified. The greeting delegate is assigned a Lambda expression where name is the input parameter and hello plus name plus exclamation point is the expression body, all in one compact line. Within a Lambda expression, the equals operator plays a crucial role by clearly separating the input parameters, which are listed on its left side, from the actual expression or statement body that defines the function's logic, located on its right side. Lambda expressions find their most powerful and widespread application when used in conjunction with LINQ or language integrated query. They are indispensable for concisely expressing filtering, sorting, and projection logic during data manipulation operations. Having covered the theoretical aspects and syntax, it's time to shift our focus to real-world applications. Let's explore several practical examples and common use cases where anonymous functions and Lambda expressions truly shine. One of the most prevalent and intuitive applications for anonymous functions, particularly Lambda expressions, is within event handling mechanisms. They provide a clean and immediate way to define the response logic for various events. A classic example involves attaching a click event handler to a user interface button. Instead of creating a separate named method, an anonymous function allows you to define the button's response logic directly at the point of event subscription. This approach offers significant advantages by allowing you to define the specific event logic precisely at the location where the event is being subscribed to. This co-location enhances readability and makes the code's intent immediately clear. Beyond event handling, Lambda expressions are exceptionally common and powerful within LINQ queries. They provide an elegant and concise syntax for performing complex data operations such as filtering, sorting, and transforming collections of data. Let's consider a practical scenario. Imagine you have a list of integers, and your goal is to efficiently filter this list to extract only the even numbers. This is a perfect task for LINQ combined with Lambda expressions. To achieve this filtering, we can leverage the where extension method provided by LINQ. This method takes a predicate, which is most elegantly expressed using a Lambda expression, to define our filtering condition. The combination of LINQ and Lambda expressions results in data manipulation code that is both remarkably concise and highly readable. It allows developers to express complex queries in a fluent and understandable manner. As with any powerful programming feature, it's essential to understand not only how to use anonymous functions and Lambda expressions, but also when and how to use them effectively. Let's explore some best practices and acknowledge their limitations. Our first best practice is to always prioritize simplicity. Anonymous functions are ideally suited for short, straightforward operations that don't require complex logic or extensive code. Avoid using them for lengthy or intricate method implementations. Secondly, a deep understanding of delegate types is paramount. Always ensure that the anonymous function you define precisely matches the delegate's signature, including its return type and the types and order of its parameters, to prevent runtime errors. Thirdly, exercise caution regarding variable capture. While convenient, capturing too many variables from the outer scope within an anonymous function can lead to unexpected behavior, memory leaks, or potential performance degradation due to closure creation overhead. It's important to note certain limitations. Anonymous methods, by design, cannot directly utilize control flow statements such as goto, break, or continue within their bodies. These constructs are restricted to traditional named methods. To summarize, throughout this comprehensive video, you have gained a thorough understanding of C# anonymous functions, including their definition, usage with the delegate keyword, and the more compact inline delegate syntax. Equipped with this knowledge, you now possess the skills to write more concise, flexible, and expressive C# code by effectively leveraging the power of anonymous functions and Lambda expressions in your daily programming tasks. The key to mastering these concepts lies in consistent practice. Actively apply anonymous functions and Lambda expressions in your own projects and exercises to solidify your understanding and become a truly proficient C# developer. Thank you sincerely for watching this tutorial. If you found this content helpful and informative, please consider liking this video and subscribing to our channel for more in-depth C# programming tutorials and educational content.